Welcome to the video demo of Scuba, which is a focus and context visualization technique for wireless mesh networks. Scuba shows routes, links, and clients. In this figure, we see the routes and links. The routes are represented as curved lines between routers and the gateways. The thickness of these lines are proportional or inversely proportional to the throughput. So lesser the throughput, thicker the lines. The color of the lines are proportional to the delay. So higher the delay, thicker the lines. We do this because then problematic routes are shown to the operator directly. The links between routers and gateways are shown as dashed lines, and the increase in the dash spaces shows that the link is broken, and that means the link has a high ETX value. In the client context, we show each client as a sector of a circle. The radius of each sector of the client is proportional to the signal strength of the frames received from the clients at the router. The angle of the arc subtended by the sector at the router is proportional to the channel utilized by the client at the router. If you hover over each client sector, you can see the MAC address of the client and the utilization and signal strength values. The halo around the router represents external interference, which is the number of clients which are interfering with the router and the clients in the network which are not part of the network. If you put all this together for the Google wireless mesh network deployed in Mountain View, California, the screen looks really messy as seen in this figure. So what we do is we show just the default route context before moving on to the other contexts. So in this figure, you see only the routes between routers and the gateways. And what you see here is if there are problematic routes, they're thick and bright, whereas the routes which are okay are not. On the right hand side top corner of the figure, you also see a small inset overview. Now this helps operators see where they are in the network when the operator zooms into the network. So zooming into the network, what appear here are the links in addition to the routes. The links again represent the dashed lines of the links represent the ETX values. In the overview, we see that the small white square represents where in the network you've zoomed into. Now zooming in further, you see that the sectors of clients with routers appear. Now, and in this view again, you see that the overview inset shows you where you are in the network. The problem with this kind of a view is that once you're focused into one particular area of the network, you lose track of what is happening on the other parts of the network. But to solve that problem, what we show here is the hyperbolic view of Scuba. So what the hyperbolic view means is, given the planar view, you project the planar view onto a hyperbolic surface, and what happens is that the focal point of the planar view appears in the center of the circle, and the rest of the points are oriented from the center of the circle on the hyperbolic space. In this view, the context of each point is decided based on how far the point is from the center of the circle, or the focal point of the hyperbolic surface. And if you if you zoom in and out, what happens is the height of the hyperbolic surface increases or decreases, and based on that, more or less contexts are shown from the center of the hyperbolic surface to the edge of the hyperbolic surface. We also used Scuba to diagnose a problem in the UCSB meshnet. The UCSB meshnet consists of 15 routers and one gateway as shown here. What you see here is there's one route which is acting bad. So what the network operator does is it zooms, he or she zooms into the location of the routes, into the link context. At the link context, you see that the quality of the links between router 3165, 2158 and 2152 GW has decreased significantly. So you know there is a problem with the links. If you zoom in further, what you see is the one client attached to 3165 is occupying 97.49% of the channel at the router. So you know that this one client is causing all the problems. So this is a simple way of diagnosing problems in wireless mesh networks using Scuba's focus and context visualization framework. Thank you.